Hi, good afternoon. Thank you for joining us today. Um, we are about to start the presentation. Please, I placed a few items on the chat, a link to a GitHub repo, so you can follow the code examples that we are going to be looking and using today. So please feel free to load that. You have that as reference. Also, you are more than welcome to scan that QR code, which also enables you to load the links towards that GitHub repo as well. But let's get started. Good afternoon. Thank you for joining us, everyone. Have you ever, if you worked for data engineering companies or in a data engineering project, and there's a series of steps that you got to do to be able to get the project going, to sort of understand the scope of the project, the requirements, and the things that are needed to be able to support what you want to do, to be able to deliver a solution. So if you ever had the question of how to get going, what are the steps that you could take to be able to do that, then this is the presentation for you. So today we are going to cover a hands-on exploration into the discovery phase for a data engineering process. So welcome. My name is Oscar Garcia. Um, my expertise are around application architecture with cloud, web, and AI technologies. I love to talk about the projects that I work with and my previous experience and the things I see in the day-to-day software engineering, data engineering activities, right? I'm also an author of the Data Engineering Process Fundamental book. And you can basically find that also on the QR code if you want to scan it. This session today is around those areas of data engineering process fundamentals where we cover the discovery phase. So to start, before we start talking more on hands-on exercise, let's talk about what is the data engineering process. Uh, um, what are we talking about when we start referring to a process, right? What is it? So it's really involves executing several steps, right, to understand the problem, the scope, the design, and the architecture for creating the solution. This is really what enables us to develop a solution for ongoing big data analysis using analytical and visualization tools. So basically, what that means is the process is really a disciplined way to attack a problem, right? To kind of understand what we need to do, what the customer needs, what we need to deliver, and how we're going to do this, right? In a very formal and process-oriented way. So today's topics really are more towards the discovery phase, right? So the importance of the discovery process. We talk about setting the stage. What are the technologies we are going to use, right? So we have an idea what technologies, but we're really not 100% on what we need to do. We talk about exploratory data analysis, right? Which is the process to be able to, as you start a project, to be able to discover what that data looks like and understand the data so you understand what to build, right? We also take a co-centric approach, right? What that means is really there are ways of attacking this discovery process, right? There are ways of using tools like visualization tools where you can upload a data like a CSV file, and you can use a visual tool to sort of kind of look at this, right? So in our approach here is kind of, we are doing a co-centric approach where we use Python, Pandas, Visual Studio, Jupyter Notebooks, and so on. We also cover something that's very important, version control, because since this has a foundation on process oriented, right? We want to be able to use the tools that you are required to use for a real process, a real project, right? And we take a look at the real world use case, so we actually know what if it is indeed practical, what we need to achieve, right? And we need to do. So please, I added the GitHub project here on this screen. You can see it. Please give us a star. So this helps us grow the project. But Let's continue. What is it? Why is it important, the discovery process? What is the importance of it, right? It's very important because it's really what gets us to identify the problem, right? By analyzing data sources, defining project requirements, establishing the project scope, right? And this also helps us in designing an effective architecture to address the identified challenges as we learn more about the project, right? So we basically need to start. So when you work for a project, the first thing they ask you is, hey, what is the problem statement, right? What is it we're trying to solve? So you need to clearly document the problem statement to understand what are we trying to achieve. We need to understand that data, right? What is the data that we need to work with, right? So we need to make observations about the data, the structure, and the sources, the frequency of the data, right? Because this will give us an understanding whether we're doing a real-time data engineering integration or we're doing a batch integration or so on, right? So those are important elements that we need to understand. We need to define the project requirements based on these observations, right? Because this helps us build the scope of work, right? This helps us understand this is really what we're going to be able to focus on and deliver with a well-defined set of objectives, right? Um, we use insights from the discovery phase to define the design of the solution, including data architecture. What that means is really as we understand the data, the frequency, whether it's a big data project, whether it's maybe not so big of data, then this helps us understand how we're going to design this. What do we need to use? What kind of cloud technologies? What kind of programming languages? What kind of resources we need to be able to understand. And by identifying this design, we can work also on a data architecture that enables us to build sort of the architecture for our data pipelines, right? Of how we're going to get the data from source to maybe a data warehouse, a data lake where the data can be consumed and processed for analytical purposes, and develop a robust project architecture that aligns with all the defined requirements and scope. What that means really is because your requirements may be that you need a real-time integration, or you need a batch process, or you need, depending on what the amount of requirements are, this is really what you need to be able to define architecture to support that, right? In case, for example, you may need um, a big cloud infrastructure, or you may need something smaller than that. It doesn't require a lot of resources. Setting the stage. Well, what are the technologies we need to use? To set the stage, we need to identify and select the tools that can facilitate the analysis and documentation of the data. So basically here, we need to be able to, as we run the discovery process, we need to identify, okay, what are we using? Are we using Python, or are we using some other language that we need? But generally speaking, these are the tools that we need to use. The technologies. Python. Why? Because it's very versatile and rich on libraries for data manipulation and analysis. We can use it for data download, cleaning, exploration, and scripting, and scripting for automation. Because as we do the discovery, it's going to be a manual process. But from the discovery, we come out with requirements. So in some of that source code that we build for discovery, we can use for the actual implementation of our data pipelines for automation purposes. We can use tools like Jupyter Notebooks, right, which is an interactive tool for creating and sharing documents containing live code. So basically, Jupyter is very powerful on not just only adding snippets of code that you can run, execute, and look at the data, but also allows you to document right away, put add the observations, add the requirements, and so on. Visual Studio Code is an excellent lightweight code editor for loading Jupyter Notebooks, Python, SQL, .NET code, JavaScript code, and so on. Very powerful tool. And really, the use cases are for writing code and debugging and doing integration with version control systems like GitHub. SQL structured query language, also domain-specific language for managing relational databases, which is very important for our data engineering projects, which we use for querying databases, data extraction, and transformation as well. This is a sort of covers your 90%, if not 100%, based on the project. But this is usually the tool sets that we can use to get to deliver a data engineering project. Exploratory data analysis, right? This is really a method for going about to learn about the data, right? This is what enables us to do downloading, analyzing, and understanding, and in addition to documenting the details of the data set. It's like going in there, because as we start a project, we don't know. We do not know what we're looking at, so we need to first get a sample of the data, and play with it and understand what's in the data. What are the columns? What are the data types? What are the values, and so on, right? So ADA is a process for analyzing data to identify also patterns, relationships, and anomalies, right? Like, for example, maybe there are bugs in there, maybe there are outliers that skew the data, and so on. And with Python and Jupyter Notebook, we can actually download the data, describe and transform the data so we can kind of understand what's going on, right? We can use the insights of this process, EDA, to set the foundation for the following data engineering steps. What that means is really, as we write our Python snippets, I mean, that can actually essentially be part of the pipeline, right? Those snippets can be part of the pipeline to execute as you automate the process. And yes, and as we write this code in Jupyter Notebook, we can export that to a Python file, which can be then added into a library for our data pipeline processes. Code-centric approach. On a code-centric approach, we use programming languages, right, and tools like Visual Studio, Jupyter Notebooks, right? This helps us understand the coding methodology for building data structures, defining a schema, and establishing relationship. So, because usually when you use other tools like visualization tools, a lot of these details are hidden from you, right? It enables you to manage the data properly and understand it and visualize it. But a lot of the things are really hidden from you. And by doing a code-centric approach, you can kind of generate the code that actually that you understand will be used on a data pipeline, on a production environment at the end. So by using code, we really can actually feel what we're really implementing in the long run, right? We by using libraries like pandas and numpy, we can actually learn the details of data manipulation, right? With like data transformation, like maybe renaming columns, maybe changing data types, or removing null values, and so on. So this gives you a real feel for what to expect from the data, right? So today we are talking about hands-on code-centric data analysis for this discovery process. Using a tool like GitHub is also very essential, right? Because this enables us to work in a collaborative environment, right? So it's just not us, but actually as we work on it, we identify it, we can actually document our stuff and push our code into a centralized repo where other team members, project managers, and so on can actually look at the documentation, look at the sample codes, and then the implementation team can come in and look at it. The test team can come and look at it, and they can start thinking about generating their test scripts, and so on, right? So this is a very, very organized way, a process-oriented way to actually handle this kind of stuff and be able to not only just push the code, but actually document what we find, right? Document the details, the observations, and so on. So it's important for centralized tracking, for sharing, for documentation, and definitely for project management. So let's take a look at what we are talking about, right? So let's learn about this. So if you notice, there is a problem statement in this screen, right? So there's a problem statement that's very important. But we're gonna read it from the GitHub project so we get a feel for what we really want to do. So when you load the GitHub repo, you will load the main page. You will see some of the details of what we're trying to achieve here, right? So, and then we will see the project statement from this project and what we're trying to achieve, right? So for example, pretty quickly, by the way, this book actually does gives us reference on everything that we're talking about today. So if you want to take a look at that, please, you are more than free to do so. Please also give us a star. You can start the project by just highlighting that star. That helps us grow this project more, please. We appreciate that. So, but we start with the problem statement. The problem statement is, in reality, that in the city of New York, commuters use the subway system to travel from point A to B, right? And there are millions of people traveling all around town. And what we want to be able to do is here identify the traffic, right, patterns for these commuters, so people can actually do sort of a target advertisement, right? So, and how do we achieve that? Well, that's process. That's part of the discovery process. But the whole idea is to sort of identify and use geofencing technology, which is just really a digital fence or virtual fence boundary around the graphic location. And then by using phones, that are pinging, once GPS is enabled, you can actually detect where certain commuters are. So the whole idea is to target them with advertisement, right? So for us, it's very important to understand then, how do we leverage this? What are the patterns for this data? How do we know the location? How do we know when people are coming in or leaving, and so on? So this is important. So the end goal of this project really is, once we take an analytical approach, right, understand the data set criteria, the end result would be a live dashboard that is going to enable the business owner, right, the stakeholders, be able to understand those patterns, be able to understand patterns of particular stations, patterns for what days of the week, what times during those days of the week, and so on. And this is a live report that will definitely, you can drill down into, and you can actually see it by following the link here in this repo. You can just actually see this live report, and you will see how you can change the dates, the station name, right, and drill down into this. If you want to just look at a particular time frame, let's say, or a day, let's say Tuesday, you can just select Tuesday. The data drills down into that, tells you, and you can just drill down more and more into maybe a time. Maybe you're targeting 12 p.m. to 4 o'clock. Maybe that's a good time for target lunch advertisement, and so on. So you can kind of see the statistics of this, right? You can do more stuff here, but this is really the end goal for this project, for us to limit the scope of work and understand what we're trying to do. So how do we do all this now? Okay, let's go take a look at the code. So once you load your GitHub repo on Visual Studio Code, right? So the first thing you want to take a look is, definitely you will see, just like you do on GitHub if you're using the browser, the different folders, right? We have the discovery folder, step 2, step 3, orchestration, data warehousing, analysis, and so on. Our focus is discovery. So what we want to do here is, in reality, is by looking at the discovery, we can start understanding what we're trying to do. So the first thing is, okay, let's go ahead and find the data. Where's the data? We need to understand where the data comes from. So if you load this file here within the step 1 discovery, there is an MTA discovery Jupyter notebook file. You can open that file, and this is what you will see. So you have here, basically, we have a notebook that enables us to document what we're trying to do, right? So we're going to start doing data loading and preparation, and we're going to do EDA, and clean the data, transform the data, and so on, right? So we definitely are going to try to do this in memory data handling. You could do it that way, or you could write it to disk. You can write the files to disk and then load them. So it's really up to you. Here we're just showing a way to do it, an approach, right? This approach can change based on what you're trying to do and how you want to do it, of course. The first thing here is, of course, we need to load all of our dependencies, right? We load all the standard libraries, right? So the way this works, once you're here, you can just click on this play button here at the top left, or you can just do Control Enter if you're using a Windows machine to run that cell. And basically what it will do is, as you load the cell, it will just do and tell you how long did it take. And now what we're going to do is, as we go through our discovery process, we sort of understand where the source of the file is. And we know it's in this website for the MTA, for the subway system, right? And what we're going to do is identify the frequency and the file format, the link format. Do we need to log in? Do we need to call APIs? Do we need to download CSV? We need to sort of understand all these details to be able to build this out. In this case, just a link for a particular date. And that enables us to download this. We can run this, and then what that's going to do is going to load a file, and it's going to load it in memory. I already done that, so we don't delay too much. It takes about 20-30 seconds to do that. It's already loaded in memory, and we created a variable called df, and that stands for data frame. That's sort of how pandas work. Data frame is just really a data structure to hold data, right? So what we're going to start doing is, once we load the data, we read the CSV, we download this file with the request library, we get it, we get the response and convert that to string, and then we read we load that string into a pandas data frame. Once we have that structure, now it's easy for us to use pandas APIs to be able to query this. So the first thing is, we'll just run head right here. So we can say, show me top 10 roads and see, and we can kind of start learning, right? What is the data? Let me rerun this to refresh it. What is the field names? What are the different things that we need to look at, right? So it may not make sense at the beginning. We're like looking at this and it's like, what is CA? What is unit? But it's part of the discovery process. We're learning about what is it that we need to discover, right? So here we're just loading the data, we're making notes, we're understanding, okay, I have a data frame and it has this, what is entries, what is exits, okay, so I kind of get a feel. Those are the facts, right? Those are the measures that we need to track. But let's continue. Let's get a little bit more understanding of what the data structure is. And we can just data frame info. And this gives us a detailed sort of a schema definition of what the data looks like, right? So we know that we have 246,000 rows. We know the column names. We know that there are no nulls based on what we're looking at here, and that the data types are object and integers. These are important because object, really what that really is just a string, right? It's just really telling us that's a string. So, and we know date and time. Maybe we would like that to be different than string, but that's what we got right now. So we understand what we need to play with, right? So when we see entries and exits already casted to an integer, so we sort of make sure, okay, that's numeric. But in some cases that's not as easy, because data may have invalid data points, right? It may have strings as opposed to numbers, or you may have null values and so on. So we need to account for that. So the first thing is we need to clean up the data. So let's go ahead and remove spaces. And if we need to, assuming that the types are not correctly, it's not the entries and exits are not casted correctly, we can cast them to integers, right? And we can remove any spaces so the data just looks clean, right? So we definitely have done that, and we can see, okay, so we have the table names. We clean them from remove any spaces in case there were any, and we casted our data types for the column that we understand that needed to be integers. But also we noticed that there are special characters on the name, some of the column names, and we may not need that, right? So we may want to check for that and remove special characters. So here we're looking for this set of special characters on line 2 of the code, right? And we're saying we don't want any of these characters here. So we're gonna write a couple of functions here to be able to clean up our data. So essentially what we're gonna do is we're gonna identify columns with special characters. So on line 21, we're gonna say, all right, if any of these columns has special characters, let's identify them. And once we identify them, let's rename the columns by removing the special characters, right? So we can run this, and essentially what's going to end up happening is that we're going to identify and map this column, the C/A was mapped to CA because we wanted to remove a special character, right? And then what we did is we renamed the data frame, right? Data frame columns, right? And you can see this function handles this. And then we do the information on the data frame, and we can see that we already renamed our columns and everything is looking as we need it, as expected so far. Okay, so now we know our data frame has clean column names and data types, and we continue. But we need to still, let's say that we still have to deal with nulls. So you can run this operation here and say, hey, give me the nulls, and if there are any nulls, fill them up with 0. And this is very, we have to be very careful here. We may want to do that, or we may want to drop the rows that are with null value. It really depends on your requirements, right? In some cases, just setting it up to 0 is good enough because you don't want to lose some additional data. But in some other cases, maybe some of those rows are completely junk or garbage, and then you can just drop them. But here, you could just do this, and basically you will look for null values. Once you have null values, then you understand your data is clean, your aggregations will work, your selections will work, and then you can basically query your data and continue, right? So we need to continue to explore the data, learn, because we don't know, we don't know really the details. We only understand the problem statement that says we want to track this based on our geolocation, right? And we know that we can see the station here, and we sort of start understanding station, maybe the data type, that the column that is going to enable us to identify the actual geolocation, right? So we continue to run this, and we notice that date and time are two separate columns. So these two separate columns may not be what we want, right? We may want to have a date time column join these two fields, and so it's easier for us for data manipulation. So we can go ahead and do that. So we can actually say just join the date and time field with this format, and then drop the date column because we don't need it anymore. And we can run that operation, and now from a date and time, from two columns, we create something, a new column called created, right? So we drop those two separated columns and we just join them into one. And now we can just query our data frame and find out that our created column is actually typecasted correctly to a date time. It's no longer an object. So now we know that we can now do daytime operations on it, which are important, right? Because we want to do things like year, quarter, day of the week, time of the day, and so on, right? So we need a daytime column for those operations. There's also the need for, depending on your project, to do a statistical analysis, right? And this works mostly for manufacturing, data science, and some of those areas, right? So statistical analysis is a very powerful, especially now with AI picking up, machine language being so popular. Statistical analysis is very important. With pandas, you can describe the data, and this will just give you some simple out of the box statistical analysis for some of what the data looks like, right? So this gives you the mean or the average, right, of roads, the standard deviation, how things are changing, and the percentages, right? I mean, we can go more into detail of this, but for us, it's really not relevant. But just understand with statistical analysis, you can actually look at, for example, identify where are failures on a process, right? So, for example, if there was a case for this data set that there are some kind of outages in particular stations, statistical analysis will help us reveal some of those patterns. And kind of pick them up, right, and understanding, or maybe outliers and things of that nature. But for us, this is more of a BI process for now. So we'll leave that, just understand that exists there. There is a huge opportunity to do projects like that. So especially with machine language. But let's continue. But what's important for us really is understand our data set, right? In our data set, we got categorical and numerical columns. This goes penetrates more into the BI, right? Business intelligence analysis, where we're actually doing, we need to do data pre-processing, and also machine language, by the way, I'm sorry. But yeah, because feature engineering, model selection, and visualization, right? So feature engineering is very important. So it's very important because feature engineering and not just for data engineering, but for machine language as well is very important because it enables us to identify the categories, right? It is important for predictive models in machine language. This is important for BI to be able to identify how to group the data, right? Group the data by, in our case, it seems to us that it appears, right, looking at the data, that we need to group the data based on a daytime um, uh, variable and also station, right? So we want to look at station one during Tuesdays at 2 o'clock and see the volume of people that are the commuters that are traveling in and out of those stations, right? So definitely model selection, right? So for machine language, you can select particular models to be able to, once you do feature engineering, to be able to understand what are you targeting, to be able to predict. So eventually this data can be plugged into a machine language model. So instead of we looking at a dashboard, you can actually predict based on certain conditions what's the best time and day to target certain customers, right? And we are preparing a presentation on discovery predictive analysis using this data set and using machine language models, and that's coming soon. So but visualization is important, right? It's how we no longer just need to read the data, we want to look at it, right? Statistical analysis, and data integrity is definitely. But this is just basically telling us areas of data engineering that we need to look for, right? So that we need to look for. So for example, how do we do that, right? So pretty quickly, what we do is we need to identify categorical columns, right? So we need to find out what columns are categories and what columns are numerical columns. And the whole reason behind that is because in our project, it's going to enable us to identify dimensions versus uh, facts, right? Versus measures, right? So, and we'll dig into that a little deeper now. But we, by running this, we're actually saying select the types that are object, right? Because there are categories, and select the types that are number. So we can actually display our categorical columns and numerical columns and kind of see what we're looking at. So this is very important. This is foundational to be able to do data modeling and machine language data model as well. So we want to display, kind of start looking at the data, see what that data looks like, and we can display unique values and kind of see. So we see that we found in this data set 378 stations, and we're just looking at the first 20 and see what they look like, right? So this starts getting into our heads into the, okay, so we have stations, we know those are locations, they're bound to a location, right, for geo location analysis. And then we can start making observations, right? We know entries are for deep commuters, people that are are getting into a subway station, so they are taking off, and exits are people that are arriving, so they're exiting the subway station, right? That's what that is. And station is what provides us the location. So we can aggregate this data based on station and the day and start getting deeper into the analysis, right? So we see the First Avenue at this particular times have this many people come in, that many people exiting, and so on, right? So, okay, so we start looking and making, this starts making, right? So let's say if we wanted to just do it by stations, and by the station, we can see the amount of exits and entries and exits, but it doesn't help us for the geo boundary requirements. But it's good to understand, right? We are kind of discovering the data and analyzing the data. We can also go data analysis by day and time. and we can want to look at it, and we can see the time frames that are there available. So we start understanding, okay, these are the times. Okay, it makes sense. This is a 24-hour operation, so they run all the time. And we can start analyzing the data. So we can use plotting, right? Another library, powerful library item, is also available in JavaScript. And you can analyze the data. So we can grab our data frame. We're going to get a subset of it. And we're just going to get 15 data rows from here. And we're just going to, for speed, right, for performance. And we're just going to create a pie chart. And we can see the distribution, right? We can see the distribution of 125th Street had 33% of the traffic here, right, of the entries, right? So we can kind of start playing with that and kind of see this. And this is foundational, right? It's foundational because this is really, if you go back to the dashboard we built, some of the stuff is what we built at the end, right? So, but this is foundational. So we kind of start understanding, okay, a pie chart looks like it makes sense for us to build, because it looks like the data is meaningful, right? So we start making those decisions. You start looking at data by the week, by the day of the week, and you run it and you see Sunday, Monday. Okay, so you kind of seeing huge numbers here, huge numbers, right? You using the created day, and then from the created day, we are basically identifying the weekday, right? So we're identifying the weekday and we're creating a mapping. So we're saying, okay, map the day of the week to a name, which is our day order, like Sunday, Monday, Tuesday, Wednesday, and so on, because that's the date of the week, right? And then we can go deeper into it and just do a little bit of more of analysis to just kind of run this and analyze it by day, right? And we can see the numbers by Sunday, Monday. This is easier to read than looking at just numbers, right? Printing out numbers. So we start seeing, okay, so we see on Sunday, Mondays, and this data set basically looks very even for every day of that week, right? So, and then we're looking at the full day, but maybe we want to look at it at a particular time frame or time slot. So we can identify our time slot based on what we're looking at, right? Maybe we just want to target morning and afternoon, and we don't care anything about midnight to 3 o'clock in the morning, and so on, right? So we create our time slots based on what we think are good for our requirements, or our, what matches our requirements. And we can just loop through the time slots and identify and map them to the created date time and match the dates. And those are important because they're eventually going to match once we generate the dashboard. That's how we create the labels for 2 o'clock in the morning, midnight, 10 o'clock in the morning, and so on. So this is important for that. And we can just basically run that, and we can see this, and we can see the statistics, right? So from midnight to 3 o'clock, 4 o'clock in the morning to 7 o'clock, and so on. And we can see those numbers, but we would love to visualize that, right? So we can just run this, use Plotly, and just go ahead and create and plot that data, as opposed to just looking at the numbers. So this is very helpful. So now we get an idea, right? So now we need to start thinking data model. So data model, we need to identify the dimensions and the facts. We already look at the columns. We sort of identify the categorical names. And so we see that this is what we need, right? We need station, we need control area, maybe the line name, and we identify the facts, right? Entries and the exit. So we can start creating, and with pandas, we can start creating sort of virtual tables, right? Data frames, basically, and represent them as tables. And we can query this data. So here we're essentially creating a dimension for station, a dimension for booth, and a dimension for, in a fact table for the entries and the exits. So essentially here we're building our tables with that data set, and we're creating their definitions, right? So we're saying this is a station table with these columns. And this is the fact tables that we're going to use, right? So we're kind of now modeling the data, right? It's giving us some insights about how to do this. So now we need to look at the data naming conventions, and maybe we're not 100% on naming conventions, and we need to apply those names. And we can run this query, run this, and basically we can standardize our names the way we want, right? And now it's making sense. Now we're creating more technical specifications, data models, and so on, right? This is important for gathering all this information. And now we have to think about it, right? If I build these models, what does that look like on a real query? How do I query this? And it's useful. So we plug in our SQL statements, and we can actually do the joins and basically query those data frames by applying a SQL statement. And basically that's going to just give us, by running the select statement, we can get that. The end goal of this here is really that, in fact, you want to be able to create your data model requirements, be able to, for the implementation team to be able to execute that, and be able to kind of understand some of the details of the data structure as you see them. Of course, implementation team will identify other things as they move forward, and they're probably going to optimize the data more as they move forward. But this gives you insights on what the data looks like, and there are no surprises, right? There will be no surprises because we are going to be able to sort of have a good understanding of what the data looks like. Of course, based on this analysis, and we write the requirements, right? So you probably want to create another file for this using Markdown. And using Markdown, we can start creating all of these details where we can actually say, okay, these are observations. These are the field descriptions that we went to the web to the company, the source, and we identify what they mean. We write our conclusions. We need to merge the daytime. The station is the location, the main dimension. Create a column is the daytime dimension to enable morning and afternoon time frames. Entries is for measure entries and exits and so on. So we document this, right? And we write requirements to enable the implementation team to do that. All right. So, and all of this is on the GitHub repo. You can actually use all of this, and you can definitely feel free to play with it. There's tons of source code. There's other things there, but please feel free to go there, visit, and do that. But in summary, is the key here is to master the discovery phase, right? Is to take a process-oriented approach, understand your data, right? Do exploratory data analysis techniques to look at the data, play with the data, understand it, create data dictionaries, create data models, and so on, right? They do data profiling to basically understand null values, missing values, outliers, right? Understand the data distributions, right? Is it meaningful? Is station meaningful for what we're trying to do, right? Do we need to use line name, which is, a station can have multiple subways running on it. So all of those details we need to identify and write as requirement based on the problem statement, right? What the business is asking us to deliver. Data cleaning, domain knowledge, setting the stage, understanding the tooling, the technologies that we're going to use, cloud infrastructure, right? Processes, whether it's code-centric data pipelines or local data pipelines. And I talk about that more in details in this book. I provide more information about that, and it covers all the entire process. So you can actually build an entire data pipeline using these data sets, to deliver that dashboard that we looked at, right? And there is also real-time integration. There's data warehousing and data lake. There's a lot more information. So thank you. I think we reached the end of our presentation, but thank you so much for joining us today. And please go follow the GitHub repo, and definitely thank you for visiting to be with us today and giving us the opportunity to talk to you today. Okay. Thank you.